page.
Good morning, ma'am.
Good morning, beta. It's page 208 in your textbooks. Theorem 10.1. The tangent at any point of a circle is perpendicular to the radius through the point of contact. So if there is a tangent to a circle, the point where it touches the circle is called the point of contact. And you have to prove that if from that point the radius is drawn, the radius will be perpendicular to the tangent. And we have started with the proof. And I told you like the proof just doesn't contain too long of an explanation. It's just a couple of lines which actually are derived or concluded from a result that we already have with us. The one I was trying to explain yesterday, that if there is a line and there is a point outside the line, or उस point से जो line के बाहर है, we draw multiple line segments to connect it with the line that we have. O को अगर हम x y से जोड़ना चाहते हैं, और अगर इसको दूसरी वे में कहा जाए, O का डिस्टेंस हम चेक कर रहे हैं फ्रॉम x y, सो आई कैन ड्रॉ मल्टीपल लाइंस O से XY तक पहुंचने के लिए. Out of all these line segments that I can draw, the one which is shortest will be the perpendicular. So that's the logic I'm going to use here कि यहाँ पे जो हमारे सर्कल का सेंटर है उसको हम अपनी टेंजेंट के साथ अगर कनेक्ट करने की कोशिश करते हैं तो जितने भी लाइन सेगमेंट्स बनेंगे वो सभी लॉन्गर होंगे दैन OP. बिकॉज बाकी सारे जितने पॉइंट्स आने हैं वो आउटसाइड द सर्कल आने हैं अदर दैन पी. यू कैन टेक मल्टीपल पॉइंट्स. राइट नाउ आई हैव टेकन इन जनरल वन पॉइंट विच इज ऑन द टेंजेंट अदर दैन पी. P is on the circle whereas Q is outside the circle. That's why the length of OQ is longer than OP. और अगर हमारे पास OP सबसे छोटा लाइन सेगमेंट है, that actually implies that OP is perpendicular to XY. So OP is the shortest line segment which can be drawn from O to tangent XY. This implies OP is perpendicular to XY. That's it. That's it with your proof. After this, we have exercise 10.1. If anyone's writing down, please let me know, else I'll just start with the exercise. And I think that can be done in the book. The first two questions are directly, yes, can be done in the book. Thank you. Page 209, exercise 10.1. First question, how many tangents can a circle have? So tangent is a line which touches the circle at a point on its boundary. So how many tangents can a particular circle have? Since circle is made up of infinitely many points, a circle is actually made up of infinitely many points, and at those infinitely many points, we can have tangent at each of those points. So the answer would be infinitely many. Now fill in the blanks. A tangent to a circle intersects it in dash point or points. 1, 2, 3, 4.
1.
That's correct. A tangent to a circle intersects it in one point, and we actually don't say that this tangent intersects the circle. We say that the tangent meets the circle or touches the circle. A line intersecting a circle in 2 points.
Secant.
A circle can have dash parallel tangents at the most.
2.
That's correct, and this is something we will be proving later in the next exercise, that अगर हम circle के लिए parallel tangents draw करना चाहें तो at the most सिर्फ 2 tangents बनेंगी, and those 2 tangents will be at the end points of the diameter. Fourth part, the common point of the tangent to the circle and the circle.
Point of contact.
Point of contact.
That's called point of contact. Question number 3, I would like you to draw a diagram for this or a figure for this one so that you can understand what it is. Okay. Is Anirai online right now? Anirai, beta, you could ask me this right now while the class is going on. Question number 3, a tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at a point Q so that OQ is 12, the length of PQ is. Now, they have used a single sentence to explain everything about this question. We have a circle with center O. The radius of this circle is 5 centimeters, and all right. Divjot beta after the class. All right. Anirai beta, I am posting it regularly. Yesterday, even I think I posted the lectures. I'll be doing it today. I'll try to do it the day I have a class. The tangent is at a point P, and this tangent meets a line right through the center. So center में से अगर हम कोई line draw करते हैं और वो tangent को meet करती है at Q. The radius of the circle is given as 5. So this is the radius. OQ is 12. So if you draw the figure incorrectly, you will not be able to mark it. What else do we have here? ये तो question में दिया है. इसके अलावा हमें क्या पता है? The theorem that we just did, theorem 10.1, using that the angle at this point of contact will be 90 degree, which makes triangle OPQ a right triangle. And now you can use Pythagoras theorem in order to find out PQ. So PQ comes out to be root 119 centimeters. The application of Pythagoras theorem, I think, can be done easily. You just need to tell me whether this is clear, how I identified these sides. Like radius is okay, radius OP, it's completely okay. The line from the center meets your tangent at Q, and that OQ is 12. You have to find out the length PQ. Anyone with any questions? And do mention this, how do we have a right triangle since the tangent is perpendicular to the radius at point of contact? Angle OPQ will be equal to 90 degree, and then you can apply Pythagoras theorem to solve your question. Any doubts?
No, ma'am.
All right. Question number 4, we are just leaving it for the time being. Draw a circle and 2 lines parallel to a given line such that one is a tangent and the other one is a secant. This is to be done with construction. You have to write down the whole theorem. You have to write down the statement that the tangent is perpendicular to the radius at point of contact. That's why angle OPQ is 90 degree. You cannot write down the number of the theorem. हम कभी भी number से नहीं indicate करते, हम simply ये लिख देंगे like the tangent is perpendicular to the radius at point of contact. That's why this angle is 90 degree and our triangle becomes right triangle, and we apply Pythagoras. Question number 4, क्रॉस मत करना, हम बाद में करेंगे after or maybe while we are doing constructions, because this is to be done using ruler and compasses. So right now we are just leaving it as such. Next topic that we have is indicated here, the number of tangents from a point on a circle. If anyone has any questions from this exercise, please ask. All right. For the next topic, I would like you to observe these 3 figures given in your textbook on page number 210. This is actually an activity, but I would just like you to observe. Page 210, there are 3 figures given alongside all this description, and I would like you to observe that point P in the first one is inside the circle. And over here in the second one, P is on the circle, and in the last one P is outside the circle. And what they are trying to do is they're trying to draw lines through P. P में से पास होने वाली लाइंस ड्रॉ की गई हैं और वो देख रहे हैं कि उनमें से कौन सी लाइन टेंजेंट बनती है सर्कल की. सो जब पॉइंट अंदर था वहां से उन्होंने लाइंस ड्रॉ करने की कोशिश की है, लेकिन जितनी भी लाइंस वो ड्रॉ कर रहे हैं इन द फर्स्ट फिगर, none of them is a tangent. Is that correct? When point P is
Yes,
inside,
ma'am.
yeah, yeah. So when the point is inside the circle, it is not possible to draw a tangent to the circle at that point. Rather, all the lines that pass through that interior point will be secants to the circle. Second figure, where point P lies on the circle, point is now on the boundary. The line that passes through P will be a tangent to the circle. There will be one particular line. As such, अगर हम P में से lines draw करें तो infinite lines हम बना सकते हैं, लेकिन उन infinite lines में से जो P में से pass कर रही हैं, there is going to be one unique line that will become tangent to the circle. Do you follow? अब ये नहीं
Yes,
कहना
ma'am.
यहाँ पे इन्होंने एक ही लाइन ड्रॉ की है, बहुत सारी बन सकती हैं, लेकिन उन्होंने सिर्फ वो लाइन शो की है जो टेंजेंट बन रही है. इट विल बी अ यूनिक लाइन. Then third figure, where P lies outside the circle, there are again infinitely many lines which will pass through P. बहुत सारी lines होगी जो P में से pass करेंगी, लेकिन there will be two lines which will be tangents to the circle. There will be two lines which will be tangents to the circle from this exterior point. And these are the three cases which have been mentioned here in your book as well. If you want to mark it, you can just mark it right here. Case 1, case 2 and case 3. अगर पॉइंट इनसाइड है वहां से कोई टेंजेंट नहीं बनेगी, अगर पॉइंट सर्कल के ऊपर है तो वहां पे यूनिक टेंजेंट होगी, और अगर पॉइंट सर्कल के बाहर है तो वहां से एग्जैक्टली टू टेंजेंट्स बनेंगी, ना दो से ज्यादा ना दो से कम. And when you draw a tangent from an exterior point to the circle, this is an exterior point or external point as they say. वहां से जब टेंजेंट्स ड्रॉ की गई हैं तो हमारे पास दो टेंजेंट्स हैं, और फ्रॉम दैट एक्सटर्नल पॉइंट टू द पॉइंट ऑफ कॉन्टैक्ट अगर हम लेंथ मेजर करते हैं, from the external point to the point of contact, this is called length of the tangent. Anyone with any questions still here? Because the
No,
next theorem is based on the concept about length of a tangent. So you should understand what length of a tangent is. जब भी बाहर वाले किसी पॉइंट से सर्कल पे टेंजेंट्स ड्रॉ की जाएंगी तो पॉइंट ऑफ कांटेक्ट से लेके उस एक्सटर्नल पॉइंट तक जो डिस्टेंस बनेगा उसको हम लेंथ ऑफ टेंजेंट बोलेंगे. The next theorem that you have is about that. The lengths of the tangents which have been drawn from an external point to the circle are equal. Now the logic, yes, of course, Japan, but I think I've done already. You might not have checked it. I did it. Like I did it. You could check it on YouTube. I have not posted the links on Google Classroom, but I have posted the videos, I guess. Maybe I have not changed the settings. I will check that after the class. So this theorem says कि अगर किसी external point से हम circle को tangents draw करते हैं तो उन tangents की length equal होगी. The first thing that we know is अगर हम किसी external point से circle की tangents draw करते हैं तो सिर्फ दो ही tangents बननी है, और हमें prove करना है कि उन दोनों tangents की length आपस में equal होगी. And as you can see, they have given a figure over here. The external point is P, and the tangents are PQ and PR. The center of the circle is O. You need to prove that PQ is equal to PR. We are going to use theorem 10.1 first of all and some construction so that we can prove this, and this will be done with congruence, as you can see. We will prove that these two triangles are congruent to each other, and once the triangles are congruent, their corresponding paths will be equal, and hence PQ and PR will have the same length. Let's write this down. I hope you remember this representation. Circle with O and radius, circle with center O and radius R. So this is the construction that we have, and I'm going to mark what I know about these. So OQ is the radius, OR is the radius. Is that correct?
Yes, ma'am.
And what else can we write down about this diagram over here? और क्या observation हो सकती है? Use the other theorem that you have. Chapter में दो ही theorems हैं. The previous theorem, what did it state?
I'm perpendicular to the radius through the point of contact.
Yes, this is your tangent, and this is the radius, and the point of contact is Q. So what will happen? The radius and the tangent will be perpendicular to each other at the point of contact. Similar thing will happen for the other tangent. The tangent PR will be perpendicular to the radius OR at point of contact, which is R. That's what we're going to write down. You don't have to write down the complete theorem. We will be directly starting with the congruence that we want to prove. I'm going to consider triangle OPQ and triangle OPR. Write down the pairs of equal sides or equal angles. Congruence कर रहे हैं, similarity नहीं कर रहे. Congruence में equality लिखनी है. So the first thing that I have is OQ is equal to OR. These are the radii of same circle. So they will be equal to each other. What else? OP and OP are equal. This is the common side for the two triangles. And then angle OQP will be equal to angle ORP. Each is equal to 90 degree. And the reason being that the tangent is perpendicular to the radius at point of contact. Can you tell me which rule is used here?
By RHS.
That's correct. This is
RHS rule.
RHS rule, and this will imply that PQ will be equal to PR. Any doubts? Is anyone writing down?
No, ma'am.
Okay. Based on this theorem, there are a few conclusions that we can infer. We are going to write those conclusions in the form of a note here. So if tangents are drawn from an external point P to a circle with center O, then these are the three results that we have. The first one is we just proved where it says that the tangents will be equal in length. तो यहाँ पे हमारे पास सर्कल है जिसका सेंटर है O, दो टेंजेंट्स ड्रॉ की गई हैं फ्रॉम P. The tangents are PA and PB. These are your tangents. The first result is that PA and PB will be equal. हमने ये प्रूव कर दिया है. उसके बाद नेक्स्ट रिजल्ट है that AOB and APB will be equal to 180 degrees. Is that true? ये वाला एंगल
Yes,
और
ma'am.
ये वाला एंगल, इनका सम 180 बनेगा. These will be supplementary. सेंटर पे जो सेंटर पे जो एंगल बन रहा है वो, और जो टेंजेंट जहां से ड्रॉ की गई है वहां पे जो एंगल बन रहा है, ऑपोजिट एंगल्स, दे विल बी सप्लीमेंट्री. हाउ डू वी प्रूव दिस? अगर हमें ये प्रूव करना हो तो क्वाड्रिलेटरल PAOB, इसमें एंगल सम प्रॉपर्टी यूज करो. So angle 1 plus 2 plus 3 plus 4 will be equal to 360 degrees. Angle sum property of a quadrilateral states that sum of the four angles of a quadrilateral is 360 degrees. But out of these four angles, angle 2 is 90 degrees, angle 4 is 90 degrees, because at the point of contact, the tangent is perpendicular to the radius. From here, I think you can conclude what I have written in note as point number 2. Is that correct?
Yes, ma'am.
ये क्वेश्चन है आपकी एक्सरसाइज में. Or sometimes, I don't think this actually, no, this is not a question, but this could be asked that the angle formed by the points of contact with the center and with the external point, they are supplementary. And then the third one, PO is bisecting angle AOB and APB. Can that be proved? The last one. Take a moment and think, can you prove this result? That's correct. So Kamjeet, just with the proof of this question, ये जो अभी आपने theorem का proof किया है, after this you could simply write down by CPCT, angle 1 will be equal to angle 2 and angle 3 will be equal to angle 4. और इससे आपका थर्ड रिजल्ट बन जाएगा जो मैंने यहाँ लिखा है, that PO bisects angle 1 and angle 3. This part will be equal to this one and this part over here will be equal to this one. Anyone with any questions?
No, ma'am.
This might seem like it's not required, but please note these down and go over these results and try to understand. कुछ ज़्यादा नहीं है, बिल्कुल simple से logic लगे हुए हैं यहाँ पे. Okay, before we do questions in the solving part, let's take up the MCQs from 10.2. Exercise 10.2, page 213. Question number 1. From a point Q, tangent to a circle has length 24 centimeters. The distance of Q from the center is 25. The radius of the circle is, you have to find out. I have drawn the figure here. इसकी figure दी नहीं हुई. I have drawn the figure for this. So I have a circle with center O. The tangent is PQ, as you can see. This is the tangent. The length of the tangent is 24. That's given to you here. The distance of point Q from the center is 25 centimeters. You need to find out the radius. Can you find out?
Yes, ma'am.
By
That's correct.
Pythagoras theorem.
By Pythagoras theorem, you can solve this. By Pythagoras theorem, you will have the answer as 25 square minus 24 square under the root. This will be root 49. The answer will be 7 centimeters. Question number 2. You have been given the figure this time. TP and PQ are two tangents to a circle with center O, so that angle POQ is 110 degrees. You have to find out angle PTQ. You can either use the result that I have stated कि जब भी external point से दो tangents draw की जाएंगी, ये जो आमने सामने angles बन रहे हैं, ये supplementary होंगे. The other way you can do this is by applying angle sum property to this quadrilateral. Tangents are perpendicular to the radius at point of contact. So angle TPO and TQO will be 90 degrees. And then you can find out angle T. What will be the answer?
70 degree.
That's correct. The answer will be 70 degrees. Option number B. Third question. Tangents PA and PB are drawn from point P to a circle again. From an external point, two tangents are drawn to the circle. The center of the circle is O. The tangents are inclined to each other at an angle of 80 degrees. You have to find out angle POA. So first of all, you need to draw the figure because उन्होंने नहीं दी हुई. And without the figure, you'll not be able to identify where angle POA is. From external point P, tangents are drawn to the circle. Points of contact are A and B. The center of the circle is O, and the tangents are inclined to each other at an angle 80 degrees. You have to find out angle POA. So the first thing you want to do is you want to join the center to the external point and then prove that triangle OPA is congruent to triangle OPB. So this will be the common side and you will have 90-degree angles here. The angle that you need to find out is this one. Can anyone tell me how do we work out this angle, angle POA?
And by angle sum property in quadrilateral PAOB.
You will be able to find out angle AOB. It will come out to be 100 degrees. What next? That's correct, Punya. But how? I'm asking you the reason.
PO bisects angle O.
Yes, PO bisects angle O by that congruence. अगर ये ज़्यादा marks में आएगा तो आप ये congruence prove करोगे. Prove the congruence of the two triangles that you have. And after the congruence, you can state that angle number 1 is equal to angle number 2. And it's actually equal to half of angle AOB. From there, you will get the value as 50 degrees. Any questions?
No, ma'am.
Question number 4. Prove that the tangents drawn at the ends of a diameter of a circle are parallel to each other. Let's write down the proof for this one. So we have a circle with center O. You can name the tangents if you want. This is what you need to prove. To prove a pair of lines parallel to each other, you either need to prove corresponding angles equal, alternate angles equal, or co-interior angles supplementary. So you can use either of those results to prove PQ is parallel to RS. The first thing that I'm going to use is, since PQ and RS are tangents, they will be perpendicular to the radius at point of contact. That would mean that angle PAO will be equal to 90 degrees and angle PBO will also be, RBO will be equals to 90 degrees. And this makes my co-interior angles supplementary and hence the lines will be parallel. If you don't want to take the angle on this side, you could take the angle on the other side as well, like over here, and then you will be able to write down that alternate interior angles are equal. Since tangent is perpendicular to radius at point of contact, therefore angle 1 will be equal to 90 degree and angle 2 will also be equal to 90 degree. But these are alternate interior angles. And are equal. This implies the lines containing these angles will be parallel. So PQ will be parallel to RS. There will be some questions which are very simple like this one, and there will be questions which will be complicated. And if you have no doubts, please let me know, like this is clear. You can just leave a message in the chat box so that we can just proceed further. And
Yes,
if you're
ma'am,
writing
it's
down,
clear.
yes, even if you're writing down, please let me know to wait so that I don't just rush
Yes,
with the
ma'am.
proof. Anyone who's writing down? Question number 5. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So this means अगर हमारे पास circle है और उसकी कोई tangent है, let us say at point P there is a tangent XY, और हम इस पॉइंट ऑफ कॉन्टैक्ट में से परपेंडिकुलर ड्रॉ करते हैं. So there is a perpendicular which is drawn right through this point of contact. You have to prove that this perpendicular will pass through the center. There are two ways this question can be done. Maybe you have done it already. One is by the proof of contradiction, by the method of contradiction. That's what I'm going to do. The second one is alternate segment theorem, which directly proves that this angle here is 90 degrees. We are not taking alternate segment theorem because it used to be in your syllabus earlier, and there used to be a थ्योरम एज सच, उसका प्रूफ हम करते थे. बट अब ना वो थ्योरम है ना वो उसका प्रूफ है, और हम उसकी एप्लीकेशन भी नहीं करते बिकॉज आपकी बुक में एज सच वो रिजल्ट ही नहीं मैंशन, तो हम वो अप्लाई नहीं कर रहे. बट आई विल डिस्कस व्हाट ऑल्टरनेट सेगमेंट थ्योरम इज. एज फॉर नाउ वी विल बी डूइंग दिस क्वेश्चन बाय कॉन्ट्रडिक्शन. So I have already drawn a circle and a tangent to the circle at point P. You want to take a perpendicular at P, but do not let it pass through P. So deliberately, we are going to join O with P. This will be one of the steps. And then there will be one more step where I have a line segment perpendicular to the tangent. Let's name it as Q. Let's first write down and then I'll discuss once again. Sorry. This will be PQ.